Good morning, everyone. How's it going today? Today, we're going to be taking a look at OpenAI Agents SDK, which is the new framework by OpenAI to create agents, and it comes as a successor from their previous framework called Swarm. The objective of this framework is, of course, to make things much more simple and minimalist, and it works with a very small set of primitives, as I'm going to show you in just a moment. You can consider this video as a crash course of OpenAI Agents SDK, both with OpenAI models and also with open models from Hugging Face. And just to tell you a little bit more about the popularity of this framework, let me show you that among the most popular SDKs for agent creation, actually, OpenAI Agents is the one that is growing the fastest, with 73% growth in daily downloads over a 90-day period, as you can see right here. It's even beating LangGraph, which is kind of cheating because now recently every single LangChain install also installs LangGraph under the hood. But even with that, OpenAI Agents is actually on top right here in growth over a 90-day period. And if you want to take a look at the daily downloads right here, actually, I'm just going to remove LangChain and LangGraph for better visibility, and also LlamaIndex because it has had some negative growth in the last few weeks. And as you can see, OpenAI is really killing it against its competitors. So this is the one that we're going to be using. Let me know if you have any questions by the end of the video. And hopefully everything's going to be very clear so that you can create your own agents. In future videos, we're going to be creating projects with this SDK. So let me know what you want to see. So let's get right into it. Okay, so the first thing to consider is that this SDK is very minimalist. And it has a very small set of very important primitives that will make everything work. The first one is the agents, which are basically the LLMs or the abstraction in charge of calling the LLMs. You have the handoffs, which is a way to have one agent delegate a task to another agent, which may be more prepared for that task because of the tools or system prompt. You also have guardrails that are built in. And you have sessions, which is basically just how to maintain the memory of a conversation in an agent across multiple runs. And I'm going to show you how all this runs in a notebook right here. And in order to run the whole thing, you have the notebook in the description right here under the video. Feel free to open that one to follow along if you want. And right here, what we're going to do first is install OpenAI agents like this. So we're going to do pip install or uv add OpenAI agents. And in my case, I'm also going to be installing Lite LLM because that is the integration that we're going to need in order to run our open source models from Hugging Face, okay? So once this one right here is installed, you're going to be able to continue. In my case, since I'm using a notebook, I'm going to run nest async.io to be able to run async code in a notebook. And then I'm going to set up my API key. And I'm going to play it like this, and there we go. And now we can actually start with the agent framework. And as you can see, it's very, very minimalist. So here, the first thing that you're going to do is you're going to import agent, function tool, and runner in order to create one function tool, one agent, and to run it. So just like in other frameworks, you have your function that is going to be turned into a tool. So you have the function which has to have a very descriptive name. You have the description of the tool, which is going to be passed to the agent in a doc string right here. You're going to have the parameters with type hints, which is very important to tell your agent or your LLM which data types it is supposed to input into these variables right here. And then you have this decorator right here, which will actually turn your function into a tool. And that way you're going to just be able to take this function right here and put it inside the tools parameter when you're initializing your agent right here, okay? So when you initialize your agent, you give it a name. In this case, it's going to be a haiku agent, and the instructions. These ones right here are the developer instructions, sometimes called system prompt, but in OpenAI systems, usually you have the differentiation between the system prompt, which is the system prompt set by the developers of the LLM, and then you have the developer prompt, which is the one set by you, the developer of your agent or your application. So those are the instructions right here. And then you have the model. In this case, you're going to be able to pass any model from OpenAI, and I'm going to show you in just a moment how to do this with Hugging Face models. And then the tools, And then in order to run it, all you're going to have to do is run with runner.run. You say which agent you want to run. In this case, it is this one right here. And then the input that you want for your agent. So I'm just going to run it right now. And as you can see, it will use this model right here to return my result after calling the get weather tool, which is the weather in this city. In New York is sunny. And since the instructions were always respond in haiku form, here I have a haiku about how it is sunny in New York, which is probably not true today. All right, and now that we have actually understood how to do this, what we're going to do is we're going to do the same thing, but with open models. And in order to do this, the first thing that you want to do is to install OpenAI Agents Light LLM integration. And once you have done that, you're going to set your Hugging Face API key to HF token. That's just your environment variable. And in order to do that, all you're going to have to do is go to huggingface.co, right here, go to access tokens, create a new access token, and give it the make calls to inference providers permission. Otherwise, you're not going to be able to call your models. Once that is done, you're going to go back to models right here, and you're going to select the model that you want to use. In this case, we're dealing with agents, so we're going to go for text generation right here, and we're going to filter by inference available, because we want to be able to run these models through inference providers via Hugging Face. So which one do we want? Let's suppose that we want to use, for example, Qwen38B. And in order to do this, you're going to click right here, and you're going to go right here to compare providers. And from here, you're going to want to make sure that the tool calling feature is active. Otherwise, it's not going to work for an agent, because remember that agents more often than not require tools, and you're going to need a model that supports function calling or tool calling. And ideally, you want one that also supports structured outputs as well, but that's only if you really need structured outputs. So in this case, the provider that we want to use is Nscale. The model is Qwen3AB, and the creator of the model is Qwen. So we're going to just copy this right here. And what you're going to do is you're going to do exactly the same thing as we did before, but instead of just sending over right here as a parameter the name of the OpenAI model, you're going to add light LLM / Hugging Face / the name of the provider that you want to use, then the name of the username or the organization that published that LLM, and then the ID of the model itself. And here in the notebook, it's very straightforward. It's written right here. That's one possibility. Another possibility is to use the light LLM class that you can import from here and just add Hugging Face / and then again the provider, which in my case is Nscale, and then Qwen38B, which is this right here. I'm just going to paste it. And in this case, let me just show you with that class-based approach. And if you want to be able to also see the usage, that is the tokens that were used on each request, you're going to want to set model settings, include usage to true. We're going to execute this, and it's going to call the function, and then by the end, we're going to have our result right here. And there we go. New York shines today, sky scratches wide, blah, blah, blah. And there you go. That is how you do the same thing with open models. Okay, now let's suppose that you want to trace the agent runs that you have. It's very important because agents can look a little bit like a black box where a lot of stuff is happening inside them, but then in the end, you only see the final result. And it's very important to see actually every intermediate step to actually be able to debug them. And it's very straightforward to do this with the OpenAI Agent SDK. All you're going to want to do is set your OpenAI API key, very important. And if you set your API key to OpenAI API key environment variable, it is going to be identified automatically. But if you set it to another different environment variable, you're going to have to set it manually using set tracing export API key like this. And once that is executed and done, you're going to be able to actually track the whole thing like this. You go to platform.openai.com, And after you have added your API key, you're going to be able to go right here to logs, and inside logs, you're going to be able to go to traces. And inside traces right here, as you can see, we have all of our agent runs. And this one right here is the one that just happened a few minutes ago. I actually forgot to rename it. It's still called Kimi Agent because I was running some tests with Kimi K2. But I'm just going to open it. And right here, you're going to see that the generation was created today with n-scale quen38b. And then right here you have the input, which is always responding haiku form. And then what's the weather in New York, which is the question from the user. And then the output, here we have the reasoning content from my LLM saying, okay, so the user is asking for the weather in New York, blah, blah, blah. I'm going to call the function. And then it returned the tool call get weather for the city of New York. Then we have the actual function call right here, and the output, which is the weather in New York is sunny, and then the final generation by my agent, which is right here saying, okay, the user asked blah, blah, blah. New York shines today, sky stretches, and here's the actual haiku, because we're, of course, taking into consideration the always responding haiku form, which is the system prompt or the developer prompt that we started off with. And there you go. That is basically how you're going to be able to trace your whole thing. Something important, if you want to trace also the usage, you're going to want to set this include usage parameter to true. That way you're going to be able to see the exact number of tokens that were used in each interaction. This is very important, especially if you're not using OpenAI models, to actually have the third-party integration give you the data about the usage, which is not always automatic. And there you go. That is how you trace your actual agent runs. And this way, this one is, of course, very straightforward and very simple. But if you have a very long agent workflow with multiple tools and maybe redundant stuff, you're going to be able to actually debug the tool calls and what is working, which prompts are causing problems, etc. Great way, and it is completely free, even if you're not using the OpenAI models. So definitely use it to improve your agents. Another thing that I wanted to show you is the possibility of generating structured output with these agents. And what we're going to do, again, we're going to be using Hugging Face models for this, and we're going to extract some data from, say, an email. So for example, here we have an example email. Hello, I just wanted to confirm the appointment with Dr. Drake Ramori for Wednesday, 5 p.m. Please let me know if there is any additional information. Best, John. And we want our agent to read this email and extract structured information from it. We want to get the name of the event, the date of the event, and the participants of the event. And it's very straightforward to do this with an agent. It can look like a simple LLM call, but of course the idea right here is that you would want to give your agent possibility of also calling extra tools, etc. Remember, this is just like a demo of the feature, not an actual project with it. So in order to use this, just like with a regular structured output call, you create a model using Pydantic base model. In this case, we call it calendar event, and we're going to pass it as output type, the parameter inside the agent, okay? And then my model is going to be the same one that I have been using before, which is this one right here, LLM. In this case, I'm going to be using GLM 4.7 from ZAI.org. And just to show you again how this is going to work, let me go back right here to models. And in this case, we're dealing with structured output. So we want to select a provider that supports structured output. And I told you I was going to be using GLM, which is this one right here. I'm just going to click on it, and we're going to go to compare providers. And right here, you can see that actually none of them supports structured output. So this is not a good model to use. Let's use another one. Let's use, for example, Kimi K2 Instruct. Okay, so we're going to select this one right here. I'm going to click on compare providers. And here we have a bunch. So we can see that the latest version of Kimi K2, if I remember correctly, it's this one. It does support structured output and function calling on both Novita and Together. So I'm just going to go for Novita. I'm just going to copy this right here, go back right here. And we're going to change this to Novita again. And there we go. The instructions are extract the calendar events from this text. The model is the one that we wanted. The output type is the one that we wanted. And then we just execute it, sending over the email as input. And it is going to give us right here the results. So the appointment with Dr. Drake Ramore, the participants are Dr. Drake and John, and the date is Wednesday. There you go. That is how you would do structured output with agents. This is of course more useful if you put it as a part of a longer workflow and you want this structured output to go maybe into another agent or to another part of your workflow. Next thing that we're going to do, let's take a look at multi-agent systems. This is a very fun part of this. All right, so for structured agents, there are mainly two paradigms that you can adopt. The first one is you can use a manager paradigm in which one agent is able to delegate tasks to multiple agents, and each agent is going to be specialized and each agent is going to behave kind of like a tool. So the agent is going to delegate the task to the other agent, and then the other agent is going to come back with a response, kind of like as it was calling a tool with an agent inside it. So it's very straightforward. That's what we would call an agent workflow. Or you can also have a handoff workflow where peer agents hand off control to a specialized agent that takes over the conversation. And it is actually that delegated agent who is going to give us the final result. It does not report back to a sort of manager. Okay. So let me show you how both of these work. And I'm going to keep using Hugging Face models right here. So I'm going to use ZAI's GLM right here. And in this case, we have two different agents. Let's suppose that each one has its own very specific set of tools, very specific set of instructions and workflows, etc. So in this case, we have a history tutor and a mathematics tutor. So the history tutor is going to have a handoff description of specialist agent for historical questions. This one right here is kind of like the tool description that your manager agent is going to be able to read in order to delegate the task to this particular agent. The model that we're using is GLM, the one that I have right here, and I have set model settings include usage set to true to be able to actually see how many tokens this model is using. And I did the same thing with the math tutor agent. And then we have the triage agent, which is going to work kind of like a manager agent or also the agent that is going to delegate the tasks. And the handoffs are essentially the agents that is going to be able to hand off the conversation to, depending on which agent it chooses that is the most relevant for that particular task. And right here, the handoffs are literally just the objects of the agents that we just initialized before. And then we can just run this using runner.run. And then we run the triage agent and can you explain the causes of World War II? So in this case, it's obviously going to be sent to the history tutor agent as we're going to see right here. And there we have the final result. So there you go. We have a pretty interesting result right here. But the cool thing to take a look at is the tracing. So let's go back to tracing right here. And in my case, it is the triage agent. As you can see, it went into the history tutor agent. So my triage agent had this generation. You determine which agent to use based on your user homework question. Can you explain the causes of World War II? That was my user input. And then the output was, first of all, it's reasoning content. It's reasoned. The user is asking about the causes of World War II. This is for the history tutor. So it performed a tool call to transfer to history tutor, which effectively delegated the task to my history tutor right here. And it is the history tutor who actually gave us the final response right here. Okay. Now let me show you how that is different from the regular agents' tools, which is kind of more of a manager workflow. So let's go back right here. And I'm going to do exactly the same thing as I did before. So I already have my history and math tutor agents initialized. The only thing that I'm going to change is that I am not going to be adding them inside my handoff parameter. Instead, I'm going to add them as tools. So right here inside the tools parameter, I have my history tutor agent.asTool. Very important, you have to add the asTool method to be able to actually call this agent as a tool. You give it a tool name, a tool description, just like with a regular tool. So then the agent is going to perform the task and give back the results to the manager agent. The same thing, we're going to be using GLM, and then we're going to run exactly the same query to show you how this is going to work. And there we go. We have the final response right here. The main causes of World War II, blah, 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 Treaty of Versailles. We have the whole thing again. But the difference in this particular run is in the tracing. As you can see, this one was of the previous run. Let me show you the one of the most recent run right here. And there we go. So we have the manager agent instead of the triage agent. And then right here, as you can see, we have the manager agent, which called the history tutor agent as a tool right here. So here we have the history agent as a tool, and here we have the response from that history agent. That is the output. And this output went back to my manager agent right here. So this one right here, here we have the history tutor, the generation of the history tutor. If my history tutor had extra tools, here I would have seen all of those tools, and then the final response from that history tutor was sent back to my manager agent, and then it is the manager agent, the one who finally actually compiled the response from my history tutor and represented it in a final response for me right here. And that's how you deal with multi-agent workflows. Of course, we're going to be dealing with more complex examples in future videos, but I just wanted to show you very quickly how this would work. All right, now very quickly, let me just go over custom tools again and pre-built tools that come with the OpenAI SDK. The first thing, as we mentioned before, is that in order to turn any function into a tool that your agents can use, you're going to have to decorate it with the add function tool decorator right here that you import straight from agents. Very importantly, also remember to always add a doc string with a very clear description of what this tool is supposed to do, because that is what your agent is going to be able to read to actually decide whether or not this tool is important or relevant to the task in question. Secondly, remember that it is important to add type hints to your functions in order for your agent to know what it actually has to send as a parameter and what it expects as a returned value from this tool. So in this case, we have a very clear example of a type hint right here. We're actually typing it with a typed dictionary. This one right here can be a pydantic model or also, for example, a data class. And right here, it's very straightforward. All you do is just define the object that this particular parameter is going to be. So in this case, it expects a latitude and a longitude. So now your model or your agent is going to be able to send that specific data type as a parameter right here. And there you go. That is a very straightforward and very simple way, super minimalist, as I told you before, method to create your tools for your agents. And actually, just before we do anything else, remember that there are also pre-built tools for your agents, pre-built by OpenAI. I would encourage you, if you're interested in any of this, to actually take a look at each one of their documentation, because they do have different specifications that you need to keep in mind. But you have a web search tool, you have a file search tool, which essentially just retrieves information from your vector stores in the OpenAI platform. And last but not least, before we leave, I just wanted to tell you that there is also streaming capabilities right here. So for example, I can just initialize my agent like this and inside an async function, because of course we're going to be working with asynchronous code, because we're going to be yielding one event after another as they happen. And what's going to happen right here is that we're going to initialize an async loop right here for each event in our stream events right here. And instead of running it with runner.run, we're going to run it with runner run streamed. And that's essentially all that's going to change. And then after that, all the events are going to be streamed. Probably going to make another video about this in the future if you're interested. Because we can not only stream the tokens, but we can also stream every single event in the agent loop. So for example, every single tool call, every single reasoning step, every single agent that that the task was delegated to, or just the tokens as we did right here. We can probably take a look at that at another video in a more thorough overview of the OpenAI Agents SDK. But for now, I feel like we have covered pretty much everything that we can cover for a crash course. You now know everything that you can do with this Agent SDK, and you can now start using it for creating your own projects. In the coming days, I'm going to be uploading a series of projects with this SDK in case you're interested. So feel free to subscribe if you're interested and you want to see actual projects being built with this SDK. Thank you very much for watching, and I will see you next time.